today's lesson is going to be 1.1 Central Tendency in the Unit of Statistics. Alright class, so take a minute, pause the video if you have to, read through these definitions. It's going to be a lot. Statistics is a lot of definitions, a lot of analyzing things. Alright, so again, pause the video. When you're done, we'll start. Alright, example 1. I want to find the mean, median, and mode for these grades. Alright, so our mean, which is x bar, okay, so we're going to add up all these numbers and then find the average of that. So first thing we need to get in the habit of is rewriting them. So lowest to highest. 64, 88, 89, 92, 93, 295s, 97, and 98. Alright, so now we gotta list them in order. So to find the mean, gotta add these all up. Alright, so just add them all up and divide by how many there are. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 9 of them. So take that, divide by 9. You can put that all in the calculator in one shot. If you're going to do it, make sure it's in parentheses. Otherwise, you can get something wonky. Alright, so it's going to be 90.11 repeating. Okay, so again, this is our mean. Alright, then our median is just the middle number in the grouping. So if you don't have a middle number, you take the average of the two middle numbers, and then that's what your median is. So since we have an odd number set of 9, the middle number will be 5. So our fifth one, we got 1, 2, 3, 4, and 5. So 93 is our median. And our last part is our mode. The mode is the number that comes up the most. So in this one, the only one that repeats is 95. So we have 95 two times, so that means 95 is the mode. Okay, not too bad. Done this stuff in previous classes or previous years. So just do another example, different numbers. Again, good habit, write from lowest to highest. It's 2.6, 2.8, 3.4, 3.5, 3.7, 4.1, and 5.2. Alright, so we got listed. Now we're going to find the average of this. We get 2.6 plus 2.8, 3.4 plus 3.5, and so on, and so on. Alright. Alright, so in a little bit, in my next part of videos, since I can't do all this by hand, I'm going to show you how to do this stuff on Desmos. Alright, but that'll come up in a later video. Alright, so we have 1, 2, 3, 4, 5, 6, 7 numbers, so divide that by 7. Alright, so our average, or our mean, is 3.6. And we got to do our median. So the nice part again is an odd number. So that means our fourth number will be our median. So we got 1, 2, 3, and then 4. So 3.5 is our median. All right, and then our mode. So look at it, none of the numbers repeat, so we write none. And that's okay if you don't have a mode. If you have multiple modes, you'll see in another example. All right, so example 3, I will show you in Desmos. All right, make a note down here. Going to, all right, and that video will follow in the part 2 part. All right, just because this shows you the graphing calculator, if you have a TI-84, you can follow these steps and then plug it all in. All right, so just take your time. Like I said, if you really want to be proactive, you can totally do it in the calculator. All right, and we'll do example 4 because that ties into that as well in Desmos. Moving along, example 5. I'm going to show you how to do in Desmos as well. Okay, so that's nice. When you use technology, it makes problems a lot easier. And then example 6 will be in Desmos as well. And then example 7 we can do right now. All right, so the percentile value, it talks about up here, is a value that divides the range of data into 2 parts such that the part below the percentile contains a given percent of data. If the number X is at the 84th percentile in a data set, then that means about 84% of the data is less than X. All right, so we have our values here. And we're going to order the values from lowest to highest. So our first one's 22. Then we have 24. And we have, this is the longest part, is organizing your data, 31. And we got 46, 47, 52, 61, 63, 63 again, 65, 65 again, 72, 81, 85, 87, 93, 96, another 96, and 2 98s. All right, phew. So we're going to find the number of values that fall between the 35th percentile. All right, so 35%. Now, if you count up our total values, there are 20 values. Okay? So 35% of 20 means we're going to take 20 times 35%, which is 0.35, which gives us 7. So we have 7 values. Okay, so we're going to identify what the 35th percentile is. So we need to go up 7 values. We got 1, 2, 3, 4, 5, 6, 7, and then 8. So the number 63 here is greater than those other 7 values. So it's greater than Yeah, it's greater than 7 value. Sorry, it's at 35th percentile. Okay, so down here, 63 is, you know, in words what I just said, is greater than 7 values. So that means, therefore, 3 dots, therefore, I'll write it down here. First time using it, therefore. Okay, it's an abbreviation. So we say 63 is the 35th percentile. Okay, highlight our answer. Bam. Alright, one last part we'll do in this first area, an outlier. So it'll give you the formal definition there, but basically an outlier is just something that doesn't fit with the rest. Alright, and at the bottom, last sentence there, it says it's a false reading. So if everything's measuring, you know, let's say like 60 degrees and then one temperature reading is 88. It's like if you're using a thermometer and, you know, you're getting 98, 98, 98, and then one time you get like 105. So it's probably the outlier. So if you take another temperature, it'll probably go back to normal. So there's a lot of things that set outliers up. Alright, so to identify the outlier, you can kind of eyeball it, but you know, again, the best way to do everything is organize it in order from lowest to highest. So 46 is our lowest. Then we have 48 and 49 and 55 2 times and 63 and then 88. Alright, so if you see it, awesome, you can write it down, but we're going to analyze the data here. So the difference between 46 and 48 is 2, 48 to 49 is 1, 49 to 55 is 6 units, we got no units, and then 55 to 63 is 8. But then 63 to 88 is 25. Alright, so this right here is a huge jump. The other ones are all small, all less than 10. So that means in this situation, 88 is our outlier. Alright, again, outlier is just that weird piece of data. If you're measuring things, your device messes up, or you know, somebody puts a wrong answer out there, or somebody can't measure correctly. Alright, it's just a lot of things that have to deal with outliers. Alright, so ladies and gentlemen, this concludes part 1. Part 2 will be posted as well, and that'll be more tutorials using Desmos on the other examples we have.